Hello. Today is June 26, 2024. This is work group serving weekly meeting. Welcome, everybody. We have a few items on agenda today. First is as a regular workstream updates, and I have a first topic on GRA workstream. On DRA front, we have work in progress PR already submitted for DRA updates, and I plan to submit plugin for device plugin failures as a pod status PR sometime late this week or maybe beginning of week after the next because of holidays. And I'm understanding that code freeze will be shifted, so there is less pressure right now. But if it wouldn't be shifted, then we only have a few days. And we also, from Signode, also have good update that OCI images as volumes. CAP was updated, and Sasha is actively working on implementation. There are a bunch of work in progress PRs already. So I think we're all on track on everything we committed from CAPs for 131 for this workstream.
Well, I just did want to say that a couple of weeks ago we talked about the scope, and there were some shifts in the scope. The partitionable model, which is what gives us dynamic big, is not going to make it. But other than that, it's more or less the same scope we talked about last time. We had a long discussion about it yesterday in the work group devices meeting. If you want to watch the recording, if you're really curious.
Thank you. And next, Ray.
Sergey, did you get a chance to have a good link to the workstream yet?
Oh no. Let me.
Okay, that's fine. Just want to bring that up because many people may wonder what's the relationship between the DRA workstream and device management group. So it might be better to clarify a little bit within that document.
Okay, makes sense. Sorry, I forgot about it. Okay.
Thanks.
Ray, you go next.
Yeah, so just to recap, we had a quick meeting last week to discuss autoscaling. The conversation was very much still around queues and how they're a sort of leading indicator of load on the model server, and the various interactions with queues makes for very interesting behavior. And so with respect to autoscaling, we were discussing what signals we can use to scale up and down. And it seems to still be converging on those queue metrics, which is very interesting. We got into some topics around how different customers would deploy this. So more sophisticated customers may have, different architectures and setups versus like more rank and file type places. So I think we need to tease those apart a little bit more, and hopefully we can discuss that in one of the next sessions we have. And then there was a topic around benchmarking. So, how can we establish a baseline and show improvements over time, especially with respect to autoscaling? So I hope we can touch on that a little bit more going forward. I think there's some proposals out there. So yeah, we're meeting again tomorrow to hopefully discuss some of these things.
Ray, I don't see any invite for tomorrow, right? Is that becoming like a regular? Maybe there is. Is that like a regular meeting then?
I've been scheduling them around the same time slot since the turnout was pretty good, and I didn't want to mess too much with timing. There is one scheduled for tomorrow. Hopefully it's showing up okay. I set it up per Sergey's instructions, but we don't have one for next week because it's a US holiday. So maybe we can pick that up again the week after if we feel like we need it.
Okay, sounds good. Yeah, I'm just wondering if there's any room to adjust the time because a couple of my teammates want to attend, but there's a conflict with our regular internal meeting. So that's like a time that we couldn't make. So we had to watch the recording to catch up.
Yeah,
but it's fine if it's too late.
Let's do it. Let's do it for the next one. Then maybe I'll ping you offline and we can figure out a time that works.
Okay, thanks.
Yep.
I guess I'll go next. For orchestration workstream, there isn't that much update. I guess these two new proposals really kept us busy, like reviewing them. I've been sharing the proposal with our internal team and the community, so that's it. Yeah.
Right. On the multi-host workstream topics, I think on June 14th, we invite Abdullah to introduce us the leader worker set and do some deep dive like discussion on how LWS primitives supports multi-host inference workloads. Yeah, I think a few community members are pretty interested in and asked a few questions, a lot of like questions on the leader worker set, not only on the like traditional touch workloads, but also like real workloads as well. Yeah, I think that session was mainly on the leader worker set discussion. We have few like other topics not discussed yet, like the KV cache transfer between like host and like the like same single model across multiple devices, like how to make the routing, etc., or GPU computing power standardization. Yeah, I think that could be some topics left to like next sessions later. Yeah, that's an update on the multi-host.
What about the networking angle? Is that covered in your mind? Is that covered under standardization of multi-device problems, or is that worth calling out separately?
If we talk about like network topology aware, like or scheduling, etc., I think that's a separate topics.
Do we have anybody lined up to discuss the KV cache transfer characteristics? I think this is extremely interesting. It could well inform how we want to basically try to improve leader worker set, or like, how we can introduce new primitives in general to handle that case. I think this is, I'm not sure if the community is aware of the dist-serve paper. They have open sourced their code, I think a couple of weeks ago. So that gives us like a concrete, like, piece of code to experiment with and discuss. I mean, I'm sure that some of these like is proprietary, like everybody has their own thing, but this one is open, and so we can use it as a common ground to discuss these things.
Yeah, the nice thing about multi-host is it's very concrete, it's hard, it's still kind of novel for a lot of people. Like I think there's really only two models that in general require more than 8 H100 out there today, although some are starting to cross the line. I think NVIDIA's was the first one I saw where the docs almost explicitly said you're going to need two 8x H100s hosts to run it. So again, I think as we discussed this in the work stream, this is a very cool area. It's definitely things that not everybody's going to hit, but everybody eventually will hit this because there'll be more and more generations of accelerators and more hardware and more model diversity. So this is a good opportunity for people who are really excited about if you have use cases, if you are using this, we can really set some of that direction and help people achieve, like the one thing that we can do that nobody else can do is help people solve multi-host effectively. Well, not no one else, but that's the area that we should be great at. So this is I still look to this work stream to generate a lot of the really interesting problems.
Sounds good.
Maybe we can discuss then, like over chat in the working group Slack channel, what we want to do next here with the. So we do have the topic, but I'm just wondering how we can push it further forward.
Yeah, sounds good.
So Dan is here. So do we want to talk about the blueprints first or the gateway first?
No, please go ahead with the gateway.
Okay. Dan, are you ready to present?
Sure.
Do you need to share the screen?
Okay, yeah, okay, sure. What my can you see my screen here?
Yep.
So yeah, so this is like a very initial like kind of strawman like a proposal like to
And you might want to make this window bigger because we can see all of your screen.
sure. Is it better now?
Yeah.
Yeah, so just give some context and background. So I think with all this the large language models, like we have like GPT and Llama, like all this like new and I think like there's a lot of like well-known models and also there's like models like from different organizations like closed source models and like from like Databricks or like from OpenAI, and so there are like various different like ARM providers. So like I think a lot of company has been looking into like how can we like leverage the also like mitigate our risk, right, depending on single like ARM provider. So like so people have been trying to like build out ARM gateway which can like support routing like your like inference requests to multiple like ARM providers. So you can like select your models like based on like depending on which model you want to use, Mistral, like a Llama, or like a OpenAI. So so you need basically a lot of company want looking into like want have the capability to have flexibility. You can like route to different like ARM providers, particularly for our scenarios. We also want to like experiment like closed models, right? In addition to all the open source like well-known models like Llama. So we need like a gateway where like you can like have a speak the standards protocol like OpenAI protocol, right? And you can like route to like have a user to like call out different like ARM models like easily. So I think that's the kind of the motivation. Like I think I talked to kind of people, so people has a lot of interest to like have this gateway, have the capability to like access like various different like providers, and also like we have like a lot of common features we want to like building this gateway, such as like we track all the cost, right? Like you pay by token or like pay by like a per request or token. So you and you also want to like do token-based limiting on the gateway, so you can like control the cost like for when you route the request to different providers. And you may also like want like a kind of more advanced like kind of routing like a strategy, like do you want to route to like a different provider based on most effective like cost, like optimized like latency or like cost, or like or like and also as well as the scalability, right? If you are sending large amount of requests, like which provider gives you the that scalability or the capacity. So yeah, so any questions? Like so that's kind of the background, like why we're looking to like and also the motivation here is like how can we like want to like see how can we engage the Kubernetes like a community, right? So build on top of the existing what do we have, like I think based on our research, a lot of the features already implemented like on in the Kubernetes like a gateway workstream, like we also had a call. I had a call like with the Envoy Gateway community yesterday also. Had a initial like a discussion like how we can like achieve this. But yeah, any questions so far?
The use cases that I think when I've looked at this, I started to feel like there were two layers or two kind of domains. There was like the really high level. I'm treating all my inference backends as different or the same, and I'm doing cost or balancing like at a really high level. I'm abstracting the provider. There's another set of use cases that I think I've become more focused on, which would be what I would call like the lower level. I don't have a good name for it, but it would be you can get efficiency wins by controlling which traffic goes to which instances, which is it has similarities to the kind of you talked about cost and rate limiting. There's other ones, which is if you want to run multiple use cases on the same model, you want priority and fairness. You may want to actually set up ratios. You want to support burst rate limiting, but you can also do things even at the lower level, like routing requests to specific model server instances that might be underloaded or have like more shorter requests so you can get different latency characteristics. Are you as interested in those use cases, or are you more focused on the higher level ones, or both?
I think it's both. Like it depends on like we don't know like exactly like a requirement yet. Like, but I think initially we may just high level ones, but I think eventually we will make it to that point as well.
Because I think I was in the stuff that I think, and I'll try to share something. I mentioned this in the chat. I'll try to share something in the next few days or so, which is kind of the lower level aspects. And I think it has a lot of similarities, but there are a few differences, and the implementations of the APIs might actually have different needs. So I at least wanted to present that so that so you and others could see, and maybe like I think there's a spectrum of features. And you mentioned Gateway. Like some of this you could accomplish with Gateway. Some of this you could accomplish just by plugging Light LLM in. Which of the parts should we go after? I think was actually what I would love to have that discussion. I very much appreciated you doing this because it was good to see someone else's thinking about this for sure.
Yeah, I think the idea is to make this architecture like a pluggable, so you can like build these like features based on the existing like a gateway. I mean like the conversation we had yesterday with Envoy Gateway like folks, we would want to like create a kind of a separate repository for like implementing these common like AI like plugins by extending the Envoy Gateway. That's like one possible approach we can do. So we can like implement these different like AI plugins like on top. Some of the features we might be able to push down, but depends on what kind of feature, whether it's like a generic like a gateway feature or like a AI specific features. Does that make sense? Yeah. Yeah, so we have looked at it into like a few projects, like in currently in this.
From Justin. Justin, do you want to ask a question?
Sure. If you're done then. I guess I liked the doc a lot. I wasn't sure what the requested action item or what the next step you wanted. Like, what is the goal? Do we want a repo? Do we want a group where we talk about it? What do we want to achieve?
I guess we first is to settle on the scope and requirement, and then I think we need to settle on a solution first, and then figure out what's the next step. How do we like based on these features and how we want to implement it? Like how can we leverage the existing like Kubernetes like community whatever the ecosystem we have.
But we want working code. Is that right?
Yeah, well, that's definitely the eventual goal, but I think we need to first figure out all the requirements, what exactly we want, and then like what's the possible choice there, and then we probably need to evaluate the pros and cons and which way we go with. I mean like initially we want to like I mean like we we want just like a roll our own like solution internally, right? But would like to check out the community if there's enough interest that we want. If everyone like have the same needs, like maybe it's better to build a community-wide like a solution, instead of we write our own like stuff like maintain it.
Well, and Dan, that the point you brought up before about Envoy is that I could kind of expect there being like a couple of layers of different primitives that people could use. Envoy plugins that multiple projects could reuse, benefit everybody.
Right.
Python plugins that you know, stuff from Light LLM. There may be people who just like people may, if you want to do ML at your proxy layer, you're going to have to use Python.
Yes.
You know, that's going to be a hard requirement. And then some people may never want to run Python at their proxy layer because that causes them to sleep badly at night. And so we might actually end up with, maybe like to your point, as we could kind of break up the chunks and talk about, you know, where we focus on broadly reusable things, where we focus on kind of, Justin, maybe you're like, where are the opinionated things and then what's in between them?
Yeah. So like we also work with like an internal team, like AI teams, like they would prefer like a Python approach, like lighter, pretty much like a lighter RM, right? So you just write a Python. Why would you need like this Envoy gateway like thing, like which is hard to understand what is you can go like a simple like a reverse proxy like a Python pin. It's just like very simple to implement, like so it's just like a two school of thoughts, and the other is like a pretty much like a Kong AI. That's what they build like based on the existing like a gateway, and they extend it like they're like a Kong like a traditional gateway and make it like implement all these. They actually exactly make this like implement all these AI plugins on top of their existing gateway. So like these are like two kind of approach like I think like a lot of AI folks may prefer the first approach, and for like us, like more like a infra team, like them, we were like leaning towards the second. And also like it's considering like because it's like a collaboration between like AI engineers, but as well as like the infrastructure team. So like we want also like it's also consideration like in terms of maintenance, like because those folks like wouldn't understand like what is XDS, like all the protocol, like it would be hard for them to extend like implement those like plugins. So yeah, that's myself. Yeah, some of the right. Go ahead.
Oh, Faye has his hand up for a while.
Oh, sorry. Can you hear me?
Yeah.
Yeah. So then just give some context. So actually, I talk with some team internally due to very, very similar things. Adding a gateway for the like a OpenAI access rate limiting with very similar purpose, but they are doing like the Kong AI approach. It's like extending the Kubernetes gateway API, add a HTTP routing extension to inject our logic here. So just share some information for you. So they are actually pretty interested to open source of some of the ways they rate limit OpenAI services to upstream. So to Kubernetes Gateway API as an extension, this is some direction that they are working on. I actually share this proposal with them to try to get some feedback from them. So I think the one feedback is that they think maybe this should be moved from the gateway API. From that perspective, get some feedback, because they are worrying if we do something here in working group serving with a completely different approach, is there any chance we are going to diverge from anything happens in networking gateway API side to doing a similar thing? I want to hear your opinion. So whether you think that's a natural, you prefer, or you feel it's better to extending the gateway API, which is pretty much the standard right away, or doing something, adding a new proxy layer sitting in between.
I think that's like I'm open for the discussion actually. we can have a conversation with them. Like, I mean, at this point, we are not settled on any of the solution yet. I'm just presenting what we want, and then, like I think we can come up a list of options, and then we can discuss later. Like, once we have a few options, and then we can discuss which way we want to go.
I was gonna say, like, I think if you think about the structures that work well in community, like, we want to have a set of people with a common set of use cases involved in both API and implementation. And Gateway as a project, was standardizing a bunch of use cases. They hear a lot of use cases. We actually I think we very much need to talk, maybe like from a project, even at a high level, is like, once we have that concrete use cases you're saying, Dan, or the set of concrete use cases, we actually need to ask, like, do the people involved in this want to use Gateway APIs? Are Gateway APIs actually the right abstraction for this problem? It's really hard to have that discussion unless you have a clear idea of who the user is. But I totally agree that, the coordination and collaboration, making sure that, like, if we do something Gateway aligned, that the folks here are meeting with Gateway. I was actually really glad to hear that you've talked to the Envoy folks. If you could link in, like, I don't know, like, if you have a link to the recording or that.
Yeah, I put some notes here. That's I put these are
awesome.
We met. Yeah, there's
yeah. This group probably is a little bit of a concentrator. I think one of the comments I added to the agenda was, I would love for us to find concrete projects that are not just Kubernetes, but they're solving the problem. Those projects may not be owned by us or owned by Kubernetes, but they should absolutely feel like they can come here, get proposals, find other interested parties. That's definitely what working group serving is about.
Yeah, that's exactly why I'm here. So it may not necessarily like the Kubernetes, like, but it's this problem we want to, see how we can leverage the Kubernetes ecosystem to solve this problem.
Sure, Dan. So if you want to have some meeting with Gateway API guys, maybe you can send a broader link. So I guess we will have some people who is interested with the conversation, because I'm trying to encourage them to kind of upstream anything that we're doing in terms of this AI traffic API gateway management to the upstream. So, but I think they are struggling. What is the right team to follow?
Yeah, that's true. Yeah, that's like definitely they are like
because they're currently working on everything on behalf, following the Gateway API protocol, just adding the HTTP extension, extending the Gateway API to do everything that they want. I think they're currently doing the rate limit already, but I think your proposal has at least some more features. I think it's a good point if we want to extend those capabilities and let them know what is the thing that upstream was doing. So we can potentially have something that we can collaborate, maybe have them to work on together if we want to have something in common.
Yeah, definitely happy to connect.
Okay, yeah, thanks.
Cool. I'm not sure, like, if we want to, I don't want to spend a lot of time here, but like I guess like these are the like high level features we will look into, like to this is like just like a scratch the ideas, like here, like we want to have kind of supporting like multiple like providers. So some configurations like we need like to configure like each provider and how we can like connect and then call these like providers. They may have like different like protocol or like authentication or authorization, like a kind of a set configurations, depending on the whether it's like Azure or like on like we can like KServe can also be another provider. Basically, if you have deployed an endpoint like ARM endpoint on the KServe side. So this is like a one component where like we want to support multiple providers. And then like the second big thing is the traffic management. Like we want like how do you like route to like multiple like ARM backends, and like how do you what are the load balancing like strategy we want to support here, at least a few of them here, like can be like usage based or like latency based. Some of them already supported by like a traditional gateway, but there's it feels like a cost tracking like a based, then you need some like a special, you will need to like extend the existing like a load balancing to implement like this like AI specific like a routing like a strategy. Yeah, a lot of the basic needs are already like implemented by gateway APIs for sure. But yeah, so it needs to be extended like yeah, there's some like AI specific routing needs like which needs to be either extended or like we'll see like some of the like fallbacks, like if you want to say like if you get really limited on one like a provider and then you want to like fall back to the other. So some of the I discussed like this fallback logic with the Envoy Fox yesterday. They say like this might be a generic feature can be like implemented in the Envoy gateway itself. So yeah, as I say, like so some of the feature may be able to push down to the gateway layer, and some if like it's very like AI specific, then we need to look into how can we extend it. Same for the rate limiting, right? So most of the gateway today only do like a request based like a rate limiting. But like for ARM gateway, we want like to do like a rate limiting but based on tokens. The import and output tokens like so this is a very typical like most of the ARM provider like do rate limiting on tokens. So this will require like extend the gateway API in some way to support like a token based like a rate limiting. But most of the configurations look exactly the same. It's just like it does different level. It's a traditional gateway does like request level, but like for ARM gateway we need to do at like a token level. But all the other configurations looks like it can be exactly the same. Yeah, I think these are the kind of high level like and there's I haven't added like there's other features like we want to like do prompt like controlling like it's just query request some like request response like transformation to like say if we want to block certain like content of the prompt content, or like you want to transform the prompt like template in some way. But that from like what I see can be easily like implemented with like Envoy like extensions or like Watson plugins, like you can easily achieve that. I was looking into this proxy Watson like a Go SDK. So it seems like a lot of features can just be like implemented here. And I think the Envoy Fox like a Gateway Fox also they I think permit these docs how you can like do external processing. And yeah, they have like some extension policy you can like extend the existing behavior. Yeah.
Jojin, did you have a question?
Yes. I'm thinking whether we have enough like motivation to create a separate projects because I mean from my personal perspective, like traffic management and rate limiting features, those we already talked about like gateway API or existing like I think Kserve use Istio. They already have such features, and we can extend those scenarios. For example, like the prompt transformation is just like a pre-filter. To me, that's a pre-filter plugin. So for those kind, rate limiter is exact the same. So for those features, is it easier to extend just in the existing like solutions which is good at traffic management, or we want to have there's something we cannot work around or cannot support? Yeah, so that's something I think we need to like discuss. And second thing is I'm just curious, like if let's say we have a solution like this, how it works with K-serve. We just talk about like K-serve because K-serve already have like a gateway there, right? And if we put a lot of like management features here, so what's the relationship between existing like Istio gateway? Yeah, that's the second question. Yeah.
So I don't know the exact answer yet, but in the future, if it depends like whether but AI gateway can be, I think can be like how to phrase it? I think like initially like, based on yesterday's conversation, they actually suggest us to create like a repository to implement these like common like AI plugins. So like for example, rate limiting like I'm not sure if we can like push down to the actual Envoy gateway level. So we might need to like extend and like implement the rate limit token-based rate limiting in the plugin. So if we have a set of common AI plugins and plus Envoy gateway, so we can like basically like much like the account AI gateway. So if that is a solution, then we can potentially offering like in case of, for example, just as some ideas like we can offering if you want the AI gateway, we can like offering we can install the Envoy gateway plus a set of like common AI plugins, which can make it a AI gateway. So it can be a installation option for K-serve, because a K-serve essentially is like I think it's in a good position to like make this offering to people. Not just an Envoy gateway, but like with pre-installed a set of like AI plugin to make it an AI gateway.
That's that's kind of an interesting point, Dan. Like the idea that we want to offer or suggest ways of configuring to solve common problems, and a lot of people, that's one of the values of Kubernetes is you have all these different ecosystem projects. A lot of people just kind of cobble together from common patterns. What can we do? Like even if it's not a full set of APIs as it's described here, but if it's pre-configured that actually gets really close to it, there's plenty of people who would be able to use that as well.
Right.
So that's a great point. So just to be cautious of time, I did want to give Abdullah a chance to go. I mean, what are kind of some next steps? So I was going to provide kind of like the LoRa use case specific that I've been exploring. You were going to have a discussion with the gateway API folks potentially that you might you'll let people know about.
I'll connect with right. So I think the next step is I'm going to create an issue under the Envoy gateway. So I think they suggest like do first create an issue so we can discuss on that issue like how we want to create a separate repo for implementing these AI plugins, and then we can go through all the features we want and how we can achieve it. So I'll open the issue under the Envoy gateway, and then also we'll connect with the gateway API folks. See what's there. So
awesome.
Cool.
Thank you, Dan. This is awesome.
Yeah. Thanks, everyone.
I can't share my screen. You want to make me a co-host or something?
Somehow I can't add you. Sergey, are you able to add?
Yeah, I just added. Yeah.
Okay. Can you see my screen now?
Yep.
Okay. Yeah, so this is a follow-up on the workload API that I alluded to a couple of weeks back. This is a proposal so we discussed, I guess, at some point that we have like three main components in general, right? Like we have the gateway, basically it receives the request and tries to route it to the right replica, but then there is the workload API that expresses how we deploy the model server itself, and like whether it's single host or multi-host, disaggregated serving, the common configurations that we have to do, etc. All of that is in the orchestrate, like the piece that like workload orchestration piece, right? Then we have also the auto scaling, and so this proposal is trying to put some framing around the workload API, proposes a design pattern that is absolutely not new. So let's just put that out there. But it tries to basically make it a bit more special for this use case. The idea here is we're going to propose that we are dealing with 4 main personas. So we've got the inference platform community, like us, that VLM community. They have the model server. They know how to configure it. They come up with new optimizations and new configurations that they want to ship to the overall community, right? We've got the platform provider like Azure GKE, who they want to deploy these, help their customers deploy these models, but they also have special, like, features. GKE has TPUs, for example. Other cloud providers have special, like, infra, I guess, optimizations to accelerate, for example, model loading. And then this is on the, let's say, like, this is one group of personas, the community and the platform provider. And then there is another one, which is the user. Generally, we are thinking that is divided into 2 main personas. It's the platform admin or the ML ops team, who wants to basically consume all of these, configurations that come from the platform community, the inference platform community, from the inference platform provider, and package them in a way that they can make it easier to use by this 4th persona, which is the workload owner, who actually wants to deploy the LLM. So given this, like, mental model of of the personas, we try to design APIs that allows us to basically make it easy for the workload owner to start and deploy an LLM server, but also help the platform admin to basically provide common configurations, canned configurations to these workload owners without the workload owner having to think about the deployment API itself, injecting all these environment variables. Some of the server flags are absolutely common. The exact hardware that we want to basically, that are allowed to run specific model. With that in mind, we've listed a bunch of goals that we're trying to address. I don't want to go through them. You can take a look at the paper. But at the end of the day, what we're trying to propose is an API to basically for the workload owner to start or deploy an LLM service, and another bunch of APIs. We're calling them, like, blueprints, templates, serving classes. We're going to decide on a naming if we get, like, consensus from the community that describes those canned configurations from which the serving deployment API will stamp out instances. There are precedents to this. KServe has, I think, the runtime concept, but we're trying to build on that pretty much. One thing we wanted to basically identify is what are, like, the main knobs that the workload owner cares about. And those are the ones that the serving deployment API, basically the API that will actually create, eventually basically triggering, creating the pods that the workload owner cares about. Just like the blueprint or the serving class they want to stamp out a deployment from. What is the model that I want to serve? The accelerators, and then overrides for some server flags or environment variables. The blueprint is basically an extensible, approach here, because we can always create a new blueprint API. So I'm proposing here a couple of basic ones that we can start with, like the single host and multi-host one. For each one, we could attach policies that allows the platform admin or platform provider to define, okay, for a specific set of, for example, VLLM serving Llama 7B on GKE. In these policies, you can define, or you can run them on H100, A100, or two, for example, L4 GPUs. The workload owner doesn't really need to basically understand, oh, I need one GPU or two GPUs to run at least one model server. This is defined in the policy already. They can just say, okay, I want H100, fall back to L4. That's another thing here that is useful. It's gonna help us also implement these, like some types of fungibility policies between accelerators types and even accelerator models as well. So like falling back between GPUs and TPUs, all of that operational complexity is going to be encapsulated in the blueprint. Again, shipped initially from the workload from the platform provider. The platform admin takes those. They could basically try to change them a little bit to better serve their use cases, but they always have this like mainstream source that they get the updates from. I want to stop here. There are many ideas that I didn't mention, and I think Clayton has like really put a really nice comment at the top about how to phrase the value proposition of these blueprints. So one thing I want to mention here is one last thing before I stop for questions is you want to try to provide some sort of like a catalog of these blueprints, basically reference deployments. We don't have a clear idea where those is going to live. Again, like they could live in a repo that the community evolves. Each cloud provider could have their own as well. But we want to create some sort of like a mechanism by which the updates that happen across blueprints are easy to apply.
I'll also note, and you kind of hit this, but and Jan, you had this in your comments, which was one of the key things that maybe we didn't call out explicitly in the doc, was in the back of my head, or not even in the back of my head, at the front of my head was, is there a way for us to define something like a serving class that everyone can use that benefits Kserve, so that Kserve doesn't have to be the place where people have to contribute serving classes, so that everybody, no matter what, like if you want to use Kserve, you can absolutely use it. If you're opinionated and you say, well, I've chosen not to use Kserve for reason X, and you contribute a serving class, and that serving class could be potential. And like, again, this is not a, we have not fully spec'd out how we would achieve this, but the mindset was, if you define a serving class or blueprint, could it be something that then could easily be used with Kserve, is composable to Kserve? But also there'll be people who maybe they don't want to run an operator, they just want really awesome curated reference architectures for, or reference implementations of disaggregated serving with VLLM. I don't think the fixation here is on the API as much. Like, maybe you have a CLI, or maybe there's a build process that takes all the blueprints and converts them to Helm charts, or converts them to, customize templates, or you can do that manually. You can provide some parameters and get back a customized template. Like, the goal of the catalog would be to be as broadly usable to the ecosystem as possible. The CRD is for all the things that Helm and GitOps aren't good at, which is mostly, strong domain-specific parameterization. Can we offer something better? And this is, one possible exploration of how we could do that.
Yeah, I added some comments in the doc, but I want to give others opportunity to chime in, especially Dan and Janu from Kserve, and maybe Andre. Do you have any feedback on that?
Like I haven't looked through this carefully. So one question that I have so we have a different CRD altogether. Is that what we are looking for, which is kind of like a LLM specific framework than a general framework like Kserve? Is that the main motivation here?
I think this is looking at the piece of Kserve that is very specific to hosting. And again, the use cases aren't like, this is a little bit less about broad inference, although I think you could make some arguments there could be overlap. It was, looking at the world from we're expecting to run huge amounts of LLM, more so than anyone has ever run any other workload in terms of amount of compute. Right now, there's such a broad range of people running LLM in all these different ways, and a lot of them are very similar. There's more variation than what K-serve expresses today, and there's a set of people who say, you know, like we hear this, like it's like we like K-serve, we like this, this, and this, but we don't want this, this, or this. So I think some of this you could argue, maybe the test question is this useful for people who are going to be rolling out LLM at scale for their companies, independent of ML in general? And then the other test question would be, can we do that in a way that actually is composable or complementary to K-serve's goals for serving classes and other things, and find common alignment? And then the third is like, is there a pattern here that would apply to other use cases? I'm not as interested in that, but like the blueprint idea is a little bit like, you've got the Wild West of GitOps. You know, everybody I know comes up with their own YAML and, you know, expansion and config language to expand into microservices. You've got operators, which lock you into a CRD, and you know the implementation is in code, and there's no way to fork. Like you have to fork the whole thing and support the whole thing. Some people do that in practice. Most people don't. Like this came up with the Kafka operator. Like there's Strimzy, and then there's a separate one. The Strimzy team also uses that to run Kafka at scale, but not everybody who wants to run a Kafka at scale service wants exactly what Strimzy has done. So I think of those as like the two extremes. I think this is targeting something in the middle, which is we expect there to be huge amounts of LLM. Like, you know, let's say 5 years from now, 50% of everyone's Kubernetes clusters are just accelerators and LLM use cases. Some of those models get much more complex internally, right? And they don't look like the high-level platform consumption. They look like there's a team that owns these LLM models that is rolling them out. And as models get more and more complex, they stop looking like something you can run on a single machine and something that you have whole teams running to support all the topology. We've seen some signs of that at Google for very large models. And so I think some of this, that's not called out in the doc, but I think that's an assumption as well, is that LLM serving today looks like deployments. 5 years from now looks like really big, complex, orchestrated stuff like distributed databases, but we're not there yet. What would be a way to simplify the near-term use cases for lots of different model servers, lots of different models, and learn some stuff in that direction? Does that answer the question, Johnny? Like, I know it's a broad question. It's just that's where we're starting.
If I understand correctly, framework which can handle LLMs as a first-class citizen than a general workload.
That is correct. This is about LLMs. This is not about any blueprint for anything, because LLMs, the hypothesis is there's like 100 standard configurations today, but you really couldn't come up with 1,000 that would make sense like the other, 500, but there's not one and there's not two. And maybe that's wrong, but like, we've got some examples like disaggregated serving fixed ratio, disaggregated serving, which is the dist serve stuff, microservices, and then single instance. More complex models we know will emerge if you have a set of big LLM components that separate out in other dimensions. We suspect there'll be more internal complexity there, but we don't need like full operator level orchestration yet for each of these. Jack, did you ask a question? We're right up on.
Yeah, I'll make it super quick. Thanks for sharing, Abdullah, and everyone else who put this together. I'm curious, I think Clayton's heard me say this in other meetings. I'm curious about the multi-cluster story in terms of scale. I know there's some comments about accelerators in terms of the new proposed spec toward the bottom of the doc. Is there any notion that these new serving APIs would be scaled across clusters, and do we want to like think of the considerations for like required during scheduling, required during execution, that long gestating but not fully complete API that's still in sort of implemented by Descheduler. But the types of advantages that you could bake into an API in a multi-cluster environment that allowed scaling to be dynamic and fluid very naturally and not super manually. Like, okay, ran out of GPUs in this cluster, shift everything over here, or my next scale out event has to happen in cluster B because cluster A and cluster C have constraints. Go ahead, sorry.
So no, I think the hypothesis, and we should write this down, we haven't written it down in any of them, would be the hypothesis would be that for the near future, there's each cluster contains a set of replicas of even the most complex models, but that not every replica of a service would be able to exist in one cluster or in one region or geo. And therefore, is a combination of, we think that the majority of the complexity is confined to a single cluster, but that the reproducibility of having a very strong control over the full configuration of that across multiple clusters would be relevant. This is, and Abdullah made a very specific design choice, and I agree with it, which is tried to focus this only on the workload part, not the serving part, which probably more aligns with Dan. So like some of the questions, like how would you balance capacity? We haven't done any provisions for how you would do multi-cluster auto scaling. I think that would be a great discussion topic for orchestration. We haven't got there yet. In practice today, dirty secret is, as far as I know, most people have 2 clusters in 2 different regions, and the bulk of their serving is in one region, and they might have some in another. And a few people are more geo-distributed. Accelerators are going to be weird, so we don't think it's going to look exactly like CPUs. But we could be wrong.
Yeah, I mean, that boundary makes sense. That puts the burden towards making the solution more natural into a multi-cluster actor and away from this. But that, if we define that boundary as such, then we can innovate.
We should definitely call out an experienced user can run a multi-cluster configuration and be able to scale replicas consistently across multiple clusters in multiple regions. And we have this called out, like we want to work within, if you have a GitOps story, whatever this does should be as minimally more complex than the GitOps that you use for multi-cluster. It should compose well with multi-cluster config distribution systems. Which ones? Most of them. And so that limits some of what this tries to do.
Thank you.
I know we're over time. Andre, do you have a quick question?
Yeah, maybe just quickly. Thanks for sharing this. So I'm just curious. So when we say making LLM the first class citizen as a workload, so what kind of uniqueness you see specifically for LLM moving forward compared to, like, for example, LVM or any other, like type of modeling, which will be in a 5 to 10 years, right, from now, and how we can make this, blueprint support all these different types and be future-proof, basically, right, for a different set of workloads in the future.
So, I mean, that's the idea behind this is like being an extensible, with the blueprints, you can always create a new API to represent a new unique type, but general enough of deployment. Why is this unique to? How is this unique to LLM? I mean, the use cases like multi-host is unique to LLM. The fine-tunes like LoRa is unique to LLM, and those we don't want them to be. We want them to be first-class parameters or citizens in this API to be able to express them explicitly. And we do see more. We will see more in the future. Like this aggregated serving is going to be something that is explicitly described here for people to basically deploy it in an easier way. So there are a number of deployment patterns for LLMs that are going to basically make it into the APIs. Like when you look at the APIs, clearly this is an LLM use case, right? Like at least for now, I've got the multi-host is clearly LLM. The idea of when you express your model, maybe you need to have a set of adapters. Again, this is LoRa, and this is mostly LLM because LLMs are huge. Adapters now becomes a thing in the LLM world. Does that make sense?
Yeah, that makes sense. I guess like the question is more for us in the community, because the beauty of KSOF, right? Like kind of like, give a way of people to using the favorite runtimes on a cluster, Torsorf or Triton or whatever they want to use, and provide this simple way for doing things. I guess the question is here, how we envision this connection between an ML ecosystem, the cloud ecosystem, by using this blueprint. And what will be like the role of us? Like, are we making the opinionated way what kind of runtime everyone will use for LLM, or we giving them a different options, right? And different set of templates so people can reuse, similar to like the cluster runtime concept. Yeah, go ahead.
So my hypothesis, and I think this underpins some of this, and this is more of a guess, is Kserve represents the ability for you to serve models that you build. And I think what I am seeing is that if you take away the need to build the model, people say, well, I want to serve this prepackaged software that is the model. And I don't need all the other stuff because I'm actually not developing the model, but I am developing aspects on top of the model. Like most people working with LLMs have some background. A lot of them right now have jettisoned all of their history, like at least the ones I've heard from is like, the enterprises doing LLM, like a lot of them haven't, like the startups, they haven't even started fine tuning models because you can prove the concept with prompting only, like input, RAG, and so what I think is kind of this weird mix is we're in this phase where there's not a lot of need to customize the model, but we haven't really landed on what the mature workflow is for fine tuning or adapting a model. And so this is very much focused on pre-canned software that we don't expect to be there to be one of, that there could be many different reasonable variations. And we want to make it as easy as possible to try so that as many people as possible can get that running. But if you're not developing the model, I don't think you don't need a pipeline that makes it easy to develop models. I think, and again, this is my perspective. I do not represent Kserve, and I do not represent Kubernetes. I'm just an individual. That would be the distinction I see. And so the best outcome for me would be that if we do have a prepackaged thing, that it still works really great and composes with use cases in ecosystem projects. And we're way over. I appreciate everybody staying. I think I'd be happy to follow up on this as well. Like this is a first step of asking the question, can we decompose parts of Kserve? It is by no means we should decompose Kserve discussion. Thank you, everybody. Thank you, Abdullah.
Thanks.
Thanks, everyone.
Thanks, everyone.